In this episode, we're going to focus on a truth that surprises a lot of new learners. Most risk analysis goes wrong long before anyone argues about threats or probabilities, because the organization does not have a clear, trustworthy picture of what it owns and relies on. People often imagine risk analysis as a clever scoring exercise, but it is really a reasoning exercise built on inputs, and the most important input is the asset inventory. An asset inventory is not just a list of computers, and it is not just something you keep for accounting. It is a map of what matters, where it lives, who depends on it, and what could be harmed if it fails. When your inventory is incomplete or outdated, you do not just miss a few details. You can miss entire categories of exposure, like data that nobody remembers exists or services that quietly power critical business functions. By the end of this lesson, you should understand what an asset inventory needs to contain for risk work, why the inputs must be verified instead of assumed, and how reliable inventory makes later decisions defensible. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. To build a beginner-friendly mental model, think of an asset as anything of value that the organization needs to protect or keep working. That includes obvious things like servers and laptops, but it also includes software, cloud services, accounts, data collections, business processes, and even relationships with outside providers. In risk analysis, the word asset does not mean a thing you can touch. It means a thing that can be harmed, lost, misused, or interrupted. A password database is an asset, a payroll process is an asset, and an application programming interface used by partners is an asset even though it is not a physical object. If you only inventory hardware, you end up with a false sense of completeness because modern organizations run on services and data more than on boxes. A reliable asset inventory captures these different kinds of value so that risk discussions start from reality rather than guesses. A key reason inventories fail is that people try to make one list serve every purpose, and then the list becomes too vague to be useful. For risk analysis, the inventory needs certain attributes that help you understand impact and exposure, not just ownership. You need to know what the asset does, what business outcome depends on it, and what would happen if it were unavailable, changed without permission, or exposed. You also need to know where it lives, like on-premises, in a cloud environment, at a vendor, or spread across multiple places. Another crucial input is who is responsible for it, not just in a formal sense, but as a real person or team that can answer questions and make decisions. Without these attributes, you can still produce a list, but you cannot reliably reason about risk because you cannot connect the asset to consequences. Classification is one of the most powerful inventory inputs, and it is also one of the most misunderstood. When you classify an asset, you are labeling how sensitive or critical it is in terms the organization agrees on, such as confidentiality sensitivity, integrity requirements, and availability importance. A beginner might think classification is only about secret data, but classification also covers how much the organization can tolerate downtime or incorrect behavior. For example, a public website may not hold sensitive data, but it might be critical for availability because it is the front door for customers, and a long outage could cause major damage. Classification helps you avoid treating everything the same, because treating everything as equally critical is a way of treating nothing as truly critical in practice. When classifications are consistent, risk analysis becomes more reliable because similar assets are evaluated using similar assumptions. Another essential input is understanding dependencies, because an asset rarely stands alone. A payroll application depends on identity services, network connectivity, data storage, and sometimes external services like tax calculation or payment processing. If you inventory only the main application but ignore its dependencies, you might rate the application as low risk because it appears isolated, while the real risk sits in a dependency with weaker controls. Dependencies also include human dependencies, like a system that only one person knows how to maintain or a process that depends on a small team that could be unavailable. For risk analysis, dependency mapping is not about drawing perfect diagrams. It is about capturing the most important relationships that turn a small failure into a big impact. A verified inventory includes these relationships, so risk work can target weak links rather than just the most visible systems. Now let's focus on what it means to build the inventory inputs, because the phrase can sound like you are just typing names into a spreadsheet. Building inputs means deciding what attributes you will collect, how you will define them, and how you will ensure the definitions are applied consistently. Consistency matters because risk analysis compares assets against each other to decide where to spend time and money, and inconsistent labels distort comparisons. For example, if one team labels everything as high criticality because they want attention, while another team labels conservatively because they fear scrutiny, your inventory will reflect politics instead of reality. A thoughtful approach uses clear definitions and examples, like what qualifies as critical, what qualifies as sensitive, and what qualifies as externally exposed. When everyone uses the same yardstick, your later risk decisions are easier to defend. Verification is where reliability is earned, and beginners should treat it as a separate step from collection. Collecting inputs often relies on people telling you what they believe is true, and beliefs can be outdated or incomplete. Verification means checking whether the asset exists as described, whether it is still in use, whether the owner is correct, and whether the dependencies and classifications match reality. This is not about mistrusting people. It is about accepting that organizations change constantly, and documentation often lags behind. A common example is an application that was retired in theory but still runs because a quiet business process depends on it. Another example is a system that moved to a new provider, but the inventory still points to old infrastructure, which makes exposure analysis inaccurate. Verification turns the inventory from a hopeful list into a reliable input. A useful mindset is to think about the most common failure modes of asset inventories and then build verification to catch them. One failure mode is missing assets entirely, like shadow systems built by departments without central visibility. Another is duplicate or inconsistent naming, where the same asset appears multiple times under slightly different names, making it look like there are more assets or hiding the true concentration of risk. A third is stale ownership, where the listed owner left the organization or changed roles, leaving nobody accountable. A fourth is misclassification, often caused by misunderstanding what data is stored or what processes depend on the system. When you verify, you are looking for these patterns and fixing them, because each one directly undermines the credibility of risk analysis. It is also important to talk about asset scope, because beginners sometimes assume the inventory should be perfectly complete before any risk work can start. In reality, you can start risk analysis while improving inventory quality, as long as you are honest about coverage and uncertainty. The trick is to focus on the assets most likely to drive major impact, like systems that handle sensitive data, systems that provide critical services, and systems that face external users or partners. These are the places where missing inventory information causes the most harm, because it leads to blind spots that attackers or failures can exploit. As your inventory improves, your risk analysis becomes more precise, and the organization can shift from broad, cautious assumptions to targeted, evidence-based decisions. The goal is not perfection on day one. The goal is a reliable foundation that improves steadily and reduces guesswork. Asset inventories become more credible when they are tied to real events and real operations rather than being treated as a compliance artifact. When a system is added, changed, or retired, that change should be reflected in inventory inputs, or the inventory begins drifting out of date immediately. If an asset inventory is only updated during an annual review, it is almost guaranteed to be wrong most of the time. A reliable approach treats the inventory like a living reference that supports operational work like incident response, change management, and recovery planning. When teams depend on it for practical tasks, errors are noticed and corrected faster, and verification becomes part of normal routines instead of a painful audit scramble. This connection to operations is what makes the inventory sustainable, which is a quiet but critical part of reliability. Another beginner-friendly way to understand reliable inputs is to connect them to the basic questions risk analysis must answer. What could go wrong depends on what the asset does and how it connects to other assets. How bad it would be depends on classification, business impact, and dependency chains. How likely it is depends partly on exposure, such as whether the asset is reachable from outside or used by many people. Whether current controls are enough depends on knowing where the asset is managed and who owns it, because you cannot evaluate controls in a vacuum. If your inventory inputs cannot support these questions, your risk analysis will end up vague, and vague risk analysis rarely persuades decision makers. Reliability is not a nice-to-have. It is what makes conclusions believable. There is also a subtle but important point about terminology. An asset inventory for risk is not exactly the same as a configuration inventory for technical management. Configuration inventories care about details like versions and settings, while risk inventories care about value, criticality, exposure, and responsibility. Those two inventories can support each other, but they are not identical, and mixing them without care can create confusion. For example, listing every small component can overwhelm beginners and hide the handful of assets that drive the most impact. At the same time, being too high-level can hide key exposures, like an externally reachable service that is critical but not obvious. A balanced inventory is structured so that you can zoom out for decision-making and zoom in when deeper analysis is needed. As you build and verify inputs, you also want to capture uncertainty instead of pretending you know everything. If the data classification is unknown, that should be marked clearly and treated as a risk signal, because unknowns often hide serious exposures. If ownership is unclear, that should be visible, because unclear ownership means nobody will reliably fix issues. If a dependency chain is suspected but not confirmed, that should be tracked so it can be verified before high-stakes decisions are made. This habit of documenting uncertainty actually increases trust, because it shows that the organization understands the limits of its knowledge. Overconfident inventories that are wrong tend to cause bigger problems than honest inventories that acknowledge gaps. In practice, the payoff of reliable inventory inputs shows up when you can defend a risk decision without relying on personal authority. If you recommend prioritizing a particular system, you can point to its classification, its role in a critical business process, its dependency chain, and its exposure characteristics. If you recommend accepting a risk for a lower impact asset, you can explain that it does not store sensitive data, it is not externally exposed, and its downtime has a limited impact. This is how risk analysis becomes persuasive rather than argumentative, because you are using shared facts. Reliable inventory inputs also make it easier to measure progress over time, because improvements in coverage and accuracy reduce surprises and reduce the number of incidents caused by unknown or unmanaged assets. That is the real educational takeaway. Inventory is not busy work. It is the factual backbone that makes risk analysis trustworthy. To conclude, building and verifying asset inventory inputs is about creating a dependable picture of what the organization values and relies on, with enough detail to support real risk reasoning. An asset inventory for risk includes more than hardware. It includes services, data, processes, and dependencies, along with clear ownership and meaningful classification. Verification turns collected information into reliable information by catching missing assets, stale ownership, inconsistent naming, and misclassification before those errors distort decisions. When inventory inputs are reliable, risk analysis becomes defensible, priorities become clearer, and leadership can make choices with less guesswork and less noise. The most important mindset for a new learner is that you do not earn credibility in risk management by sounding confident. You earn it by grounding decisions in accurate, verified inputs that the organization can agree on and maintain.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.